Okay, guys, got a time of flight question here for A-level chemistry. So let's go through the maths of this one. They've given us the equation for kinetic energy, and they've given us the units that we need to use in the equation. They've also told us that we need to calculate the time. Notice time is not in this equation. We've got to calculate the time that the ion travels down the flight tube to reach the detector. They've also shown that we're going to use Avogadro's constant at some point in this series of maths calculations. Well, one thing we can pick up on is that we've got distance and they want us to calculate time. And in science, when you need distance and time, you've got to go to the old speed equation. Speed equals distance over time. Here we're using v for velocity, but you could interchange that with speed. It doesn't really matter. Okay, guys, so the first thing I want to do here is rearrange this equation. We need to make velocity the subject so we can then carry it over to our speed equals distance over time equation. First thing to do is get rid of this 2 at the bottom. I do that by timesing both sides by 2. That gets rid of the 2 on the right, and it leaves the 2 on the left. So we end up with the next step after we've done that is to divide both sides by m. And that gets rid of the m on the right. And then finally, we need to square root both sides to get rid of the square on the v. And there we go. We've got the velocity. So we need to work this out now. So the next step, we are going to times the kinetic energy, which we have here in joules, by 2. And what you'll find when we do that is we get a number of 2.204 times 10 to the minus 13. Super duper duper. We need to divide this by the mass, and then we're going to square root it. So let's now go ahead and work out the mass. This bit some people find a little bit tricky. It's a chromium positive ion, but we know the chromium ion has a mass number of 53 grams per mole of chromium 53. Well, this question is not asking about a mole. This question is actually asking us about a chromium ion, so a single unit of that mole. And we know that mass has to be in kilograms. So what I want to do here is convert this into kilograms. And in order to do that, I'm going to divide by 1,000. We get 0.053. Lovely. That's kilograms. That's still for a mole. So there's 0.053 kilograms per mole. Let's find out how much one ion weighs. Well, there's that many ions in 1 mole. So in 0.053 kg, we've got that many ions. Okay, so now we need to take the mass of 1 mole and divide it by Avogadro's constant. This will give us the mass of a single ion. It should be a really, really small number. And it is 8.8 times 10 to the minus 26. Okay, let's put the mass back into the equation. So we're going to divide 2 Ke by the mass and then square root it. First of all, let's divide 2 Ke by the mass. We're going to get 2.5 times 10 to the 12. Square root that, we're going to get 1,582,575. 1,582,575 meters per second, more or less. Okay, so let's take that distance of 1.25 meters, divide it by the velocity, and that's going to get us the time. So 1.25 meters divided by that massive velocity equals 0. Oh my gosh, so many zeros. There's 7 zeros basically, 78985. And as it's 789, we can round that to 79. So really, this is 7.9 times 10 to the minus 7. And that's seconds. So 7.9 times 10 to the minus 7 seconds. That's the time. Right, guys, that's your 5 marks. Subscribe, hit the like, and let's get to the marks in time for those summer exams. Good luck.